Page 2 of the study guide. Question number 6 says, cross a parent that is homozygous dominant and a parent that is homozygous recessive and display the results in the F1 generation. So you've got your big H for your homozygous dominant, your little h for your homozygous recessive, and you find that all of the offspring come out heterozygous with dominant phenotype, big H, little h. What genotype would each parent have if 50% of the offspring come out with a dominant trait and 50% come out with a recessive trait? So I did a Punnett square here to help figure this out. The parents would have to be heterozygous and recessive. So big H, little h, big H, little h, little h, little h, little h, little h. So there's your 50% with the dominant phenotype, 50% with the recessive phenotype. Number 8 says, what does crossing over of a chromosomes during meiosis provide? So during the prophase section of meiosis 1, chromosomes are going to cross over. And this is going to provide genetic variation and diversity. I'm going to show you that slide on the PowerPoint. You can see crossing over occurs in prophase 1 of meiosis. And it is when the chromosomes basically just, like we said in class, they rub on each other and swap information, so you end up with a little bit more variation than you had before. This is going to increase genetic diversity. It's going to scramble things up a little bit, and it's good for variation. It's good that that happens. It increases genetic variation and genetic diversity in sexually reproducing organisms. Let's see if we can get that back. Okay. Number 10 says, what sex chromosome combination is male and which one is female? XX for female, XY for male. And one of the video clips we watched this week, the guy said if there's a Y, it's a guy. Just something that rhymes to help us remember. What are sex-linked traits and why are they more likely to appear in males? Okay, sex-linked traits are attached to the sex chromosomes. So anytime they are found in men, they're going to be expressed in the phenotype. So again, if you want to look back at the presentation, this started on slide 49, where we started talking about sex-linked traits. It was discovered in 1910 by Thomas Morgan Hunt. Some genes are attached only to the sex chromosomes, so the X or Y chromosomes. In men, these are going to be presented in the phenotype anytime they're there. So that's why there's more men who are bald or colorblind. In women, it's much more rare because you would have to have 2 genes to show that trait. So we know, because of sex-linked traits, we know that if you're going to be bald, you inherited that from your mom's side of the family. This is a great slide that kind of demonstrates how that happens. Here you've got mom as a carrier. The females that could potentially come from this crossing would be, one would be a carrier, one would not be. The males that could potentially come from this crossing, the male, there's a 25% that you would be in bald male and a 25% that you would not be a bald male. Or if you were male, it's basically a 50-50 shot. And then this shows how it's not inherited from your dad's side of the family. All right, so we're talking about the roan cow again. What would the resulting offspring look like from a cow that was a red cow crossed with a white bull? I guess one of them has to be a bull. So big R, big W is going to come out with your big R, little w, big R, big W, big R, big W, big R, big W, big R, big W. We're going to use capital letters when we do a Punnett square to show co-dominance, 2 capital letters. If for some reason this trait was incompletely dominant, not co-dominant, how would the alleles be displayed differently? And in an incomplete dominance case, you end up with an intermediate phenotype. So you end up with a paint can effect or a blending of the two. And in incomplete dominance, you end up with this intermediate phenotype that doesn't look like either of them. So if we crossed a red cow with a white cow, we would end up with a pink cow. I like to think of incomplete dominance as the paint can affect. They're both equally strong, so you end up with an intermediate phenotype, so something different than you had before. And that's it for page 2.